see the same exact code. So this is a p-value question, a binomial p-value question. So your friend claims that they can distinguish between cheap and good wines, and so you randomized a bunch of varieties. So you got a cheap Merlot and an expensive Merlot, and you gave them to your friend in random order, and then you got a cheap Chianti and an expensive Chianti, and you gave them in random order. And she got 5 right out of 6 varieties that you tried. And the question is, what's the chance, if she was just flipping a coin each time, what was the chance of getting 5 or more right? So 5 or 6. That would be the p-value. That would be the probability of getting as or more extreme evidence in favor of the alternative, assuming, where the probability calculation is done, assuming that the null is true. All right, so let's just do that. So we want the binomial probability of 5 or 6. Okay, if the coin were fair out of 6 trials. Okay, so we want p binom, we want 5 or 6, so I'm going to put 4 here, and I'll explain why in a second. I want size, the number of coin flips equal to 6, the prob is equal to 0.5, 0.5, and lower dot tail equals false. Sorry, working on a small keyboard here. There we go. So it's 11% if I round to the nearest integer percentage. The reason I do 4 is because by default p binom will do 4 and lower, but then when I put lower dot tail equals false, it's going to do strictly greater than 4, so 5 or 6. Okay? So as an example, if I were to do 1 minus p binom where I omitted the lower dot tail, it's going to give me the same number, 11%. Okay? So if I do p binom 4, it's going to give me 4 or fewer, and if I do p binom 4 with lower dot tail equals false, it's going to give me strictly larger than 4, which is 5 and 6. So the two p binom 4 without the lower tail and p binom 4 plus the lower tail have to add up to 1. So I'm going to go here and plug in 11%. And then I'm going to click show answer, and it's going to show it. I round it to, I guess, an extra decimal place there to give 10.9.